Hey there, y'all. Today we're going to look at 1.4 on radicals and rational exponents. The objective here is that you'll be able to simplify expressions that have radical and rational exponent notation. And it falls under these two standards of NR/NS, being able to rewrite expressions from simple radical and rational forms, and the definition of rational exponents being able to translate to rational exponent and radical forms. So as we look at this first part of the section, what I want to call your attention to is this symbol first. And so this symbol is called the radical. Now, the different parts of the radical that we have, if we see this example over here, we're going to look at the number underneath and the number that could sit up top. Now, for doing square roots, we don't put a number there, but if we deal with cube roots or fourth roots or any higher powered roots, we're going to put a number there. And that number is called the index, and it tells us what root we're taking. And so again, if there's no number, we assume it's 2, and that means we're doing square root. But if there's a number there, we take that root. And we'll talk more about those later on. I just want you to know the name of it for now. The n is called the radicand. Radicand. And so that's the number that's under the radical, and it's telling us what we're taking the root of. So for example, when we look over in our table, like the square root of 25, right? And so what does the square root of 25 mean? Well, the square root of 25 means what times itself is going to give you 25. So what times itself, the same numbers here, give you 25. Well, 5 times 5 is 25, right? And so square root of 25 is 5. Now, I'm going to pause the video and fill out the rest of this list because I want you to have these numbers as well. So get these numbers copied down and we'll look at this list in a second. So here's all the values here. I would pause the video for a second here so that way you can get this all copied down into your notes, and then we'll talk about how we get these numbers and what they mean to everything else that we do. So where do we get these numbers from? Well, remember that when we square something, we're saying 0 times 0 is equal to what? 0 times 0 is 0, right? Or 4 times 4 is 16. And so we call these our perfect square numbers because they are the product of themselves, right? So 4 times 4 is 16. So 16 is a perfect square number. Or 81 is a perfect square number because it's 9 times 9. Now, we call these perfect square numbers because if I were to draw a square, right? And I was talking about like maybe the area of a square room. And this side was 12 feet and this side was 12 feet, then I would get 144 square feet, right? And so again, that's where these perfect square numbers come from because we're talking about a square. Now, we look at the square roots, remember that undoes a square. So, if I have a perfect square number like 100, what is the square root of 100? Well, it's one of these numbers here, right? So, if I take the square root of 100, that means what times itself gave me 100, and that is just 10. We don't write 10 times 10. We just write the 10. So, we're going to look at a couple practice problems here. And so we're going to estimate some of these here. And we want to know where they fall on the number line. And so that's the biggest thing, is we have these perfect square numbers, right? And so like square root of 22 is going to be here. And we want to look at two square roots that are above or below it. And so come back to our table for a second. What numbers on our list give us in between for square root of 22? Well, it falls between the square root of 16 and the square root of 25. And so I'm going to get the square root of 16 here and the square root of 25 here. And so this falls between what values? Well, square root of 16 is 4 and the square root of 25 is 5. So that means the square root of 22 is 4 point something. Now, we can estimate a little bit if it's closer to one end or the other and say it's about 4 point something. The biggest thing to know is it closer to 4 or is it closer to 5? This is going to be closer to 5. So this is going to be like 4.7 or 4.8 if we were to go to our calculator. All right, so let's look at one more example of this, and I'm going to ask you to try the other three. So, again, we want to draw a number line here. We're going to put the square root of 75 in the middle of this. If we go back up to our table in the list, 75 falls where? Between 64 and 81. And so I'm going to put those two numbers here. square root of 64, square root of 81. And so this is 8, and this is 9. Meaning that the square root of 75 falls between 8 and 9, meaning that this is 8 point something, right? Because in between those two numbers. Now, square root of 75, is that closer to 64, or is that closer to the square root of 81? So it's closer to 81, right? Because 64 would be 11 units away, and 81 is only 6. And so this is going to be about 8.6 or 8.7. Again, just estimating about where this would fall. Could I go to a calculator and get the exact value? Of course. But we want to have an idea about what this number is going to be so we could use it elsewhere very quickly. All right? So I want you to do the same thing for these other 3 examples. Draw yourself a little number line, put that square root in the middle, figure out which 2 are going to sandwich it, and then figure out what this is going to be about. And again, if you're off by 1/10 or 2 by what I say it is, that's fine, because it's an estimate and we're just trying to get it in the ballpark. Now, if you say the answer is like 8.1 to number 2, that's off because we're not sitting over here at 8, right? We're sitting closer to 9. So make sure you get it in the ballpark, all right? So pause the video here and then try those 3 problems. All right, so if you look at the square root of 300, I'm going to shift this off to the right a little bit. Square root of 300. What 2 things are going to sandwich that on our list? Well, 300 falls between this 289 here and the 324 here. So square root of 289, square root of 324, and the square root of 89 is 17, and the square root of 324 is 18. Which are we closer to, the 289 or the 324? Well, 300 is only 11 away here, 24 away here. So it's going to be 17 point what? Again, it's not quite to the middle. This is probably going to be about 17.2 or 17.3. Again, if I want a precise answer, we can go to that calculator and get it. Look at square root of 40 here. What's it between? What do you have on the left? We have the square root of 36. On the right is the square root of 49. Square root of 36 is 6. Square root of 49 is 7. So what is this going to be? 6 point something, right? And so which is it closer to? Is it closer to 6 or is it closer to 7? It's closer to 6. So this is going to be about 6.2 or 6.3. It's not quite in the middle, so we're not going to get to like 6.5. All right, last one of these 5. Square root of 62. That's going to fall between what and what? The square root of 49 and the square root of 64. So this is between 7 and 8. So this is 7 point something. And 62 is really close to 64, right? So this is probably 7.9 something. It's really close. So we're going to use that 7.9. Again, it might be like 7.87 something or 7.88 something. But rounding to the tenths, it would round up to a 9 anyways. So that's what we're looking at with those examples there. So the next thing we're going to look at is how to simplify expressions with rational exponents. And so what we're doing here is we're going to convert from an exponent to a radical or vice versa. And so if we're given just this, we can convert it to this or vice versa. And so a couple key things here. The base needs to be larger than 0, or it could be 0. And the n has to be an integer. Remember what integers are, right? So, but they need to be greater than 1. So we can start at 2. 2, 3, 4, 5, 6, and so on. Okay? And so what does this mean, this definition? We're talking about being able to take like 2 to the 1/5 power and rewriting it as the 5th root of 2. Because the number here will become the number here. Okay? So let's look at a couple examples of this. We want to rewrite these exponents into radical form. So we have in example 1a here, 64 to the 1/3 power. And so what's going to go where? The 64 is going to go inside the radical, and then this denominator will become the index. So this becomes the cube root of 64. Now, if we went to our calculator, we could find the cube root of 64 and get an answer, but that's not what we're worried about here. We want to just convert it from rational exponent form, that's what we call this, rational exponent form, to radical form. Now, if we do want the answer here, the cube root of 64 is 4, because 4 times 4 times 4 is 64. Because when we do cube root, we're looking for 3 times together to give us this number. And again, all three of these would be the same value. In B, we have 32 to the 1/5 and minus 81 to the 1/2. So we're going to convert both of these, simplify it down, and subtract in the end. So 32 to the 1/5. So that's going to be the 32 inside the radical, and we're going to take the 5th root of that minus the radical with 81 inside, and we're doing square here, right? So do I need to put a number here? No. Because remember, if there's no number there, we're doing the square root, all right? So what's the 5th root of 32? So ask yourself, what times itself, times itself, times itself, times itself gives you 32? It's actually a really small number. It's just 2. So 2 comes here, minus, what's the square root of 81? That's on our table above, right? Minus 9. And 2 minus 9 is negative 7. So again, when you're dealing with these problems, think about the powers, think about what you're dealing with, and how many times it's being multiplied together to get that one value. Because remember, when we take a root, we're not going to write it 5 times like a 5th root here, but we're going to write it just once and deal with it from there. Okay. So we're going to review some properties here. These properties are ones that you should have looked at in 8th grade math, but we're going to just check them out here and talk about their properties. So the product of power properties says this, that if I have the product of two bases that are the same, I'm going to do what with these powers? I'm going to add them. And so an example here, if I have x to the 4th times x to the 5th, we're going to add those powers together and get x to the 4 plus 5, which simplifies to x to the 9th, right? Quotient of powers works the same way. And so if I have the same base, x to the 4th over x to the 3rd, I'm going to subtract those powers, so x to the 4 minus 3. And so that gives me x to the 1st, or just x. Now, what we put in here can be a number, can be a variable, can be any sort of thing. It doesn't have to be just a single variable here. It can be like 5. I could do 5 to the 4th times 5 to the 5th and have to add those exponents. We won't add the base, though. Understand that the base does not change when we do these powers. The base stays the same. Okay? Third property is the power of a product property. And this is where we have two different bases. So if I have like 3x here and I want to square it, and we have parentheses around this, this square is going to go to both pieces of the product. It's going to go to the 3. It's also going to go to the x. So what I'm going to get is 3 squared times x squared, which gives me 9x squared. That's what we get there. All right. Power of a quotient property works the same way. And so if I have like x over 5 and I want to square it, again, the power will go to both. And so I'm going to get x squared over 5 squared, and 5 squared is 25. So again, the power's got to go to both. It's got to be able to simplify. In both of these quotient properties, understand that the denominator, of course, cannot be equal to 0 because we can't divide by 0, right? We talked about that in the last section. All right, the last two properties here, power of a power property. This is one where if I have like x to the 3rd and I raise it to the 4th power, we're not going to add these powers here. We're going to multiply them. And so I'm going to get x to the 3 times 4, which gives me x to the 12th. Now, we can expand this out and talk about why we get 12 here, and if you want to look at that, we'll talk about it in class. But understand that we're going to multiply those powers in this case, not add them. Last property is the negative exponent. So if I have something that has a negative exponent, and so let's say I've got like 4 to the negative 2nd power, that's going to convert to 1 over 4 squared. Because the powers, when we switch it from the numerator to the denominator, the power is going to switch its sign, just the power, not the base. But the power switches signs. And so then now it's gone to the denominator in this case. And so what is 4 squared? It's 16. So this is actually 1 over 16. Okay? And so let's look at a couple problems here of how to simplify these. Now, when we're talking about these, we're talking about just a little bit different here from what we looked at before. With these, we're going to still do the same property we did with the denominators, but the numerator goes in a different place. So the property here is this. It's that if I have b to the m over n, the index is still the n, and the b goes inside. But now I've got a power going out back, because this part will still do what it does, and the power stays where it stays. It's the best way I can explain it. I mean, we can talk about it a couple of different ways, but that's the best way to explain it. The power is going to stay there. The rest of it converts to what it's supposed to convert to. And again, there's a couple of different ways I could show that to you if you want it a different way. So in this first one here, the 125 to the 2/3 power. So I'm going to take the 125. It's going to go under the radical. The index, remember, is the number in the denominator of the radical. It's going to be 3, so I'm taking the cube root here. But then I'm going to square that after the fact. So what is the cube root of 125? What times itself is going to give you 125. That is 5. And so 5 squared is equal to 25. Okay? I want you to try example B here. So pause the video now and look at example B. So in example B, we've got 81 to the 3/4 power. Again, think about what parts need to go where. Remember, your base is going to go under the radical. So we get the square root, or not the square root, but the radical of 81. And then the denominator is going to go where? It's the index. And that power on the back, that 3, is going to still sit there, right? And we're going to deal with it second. What's the 4th root of 81? So what? Times itself, times itself, times itself is 81. It's a small number again. It's just 3. And so I'm going to get 3 to the 3rd. And 3 to the 3rd is 3 times 3 times 3. That's not 9. 3 times 3 is 9. But times it by 3 again. And we get 27. So again, pay attention to your multiplication and how it's working through. But that's the key thing there. All right. Last example here. We're going to look at this word problem here. The approximate number of calories that an animal needs each day is given by C is equal to 72 m to the 3/4 power, where m is the animal's mass in kilograms. Find the number of calories that each animal needs daily. And so we're told that a Siberian tiger has a mass of 256 kilograms. And so understand where this is going to go into our problem. C is equal to the 72. This is our mass, and that's m, so 256. To the 3/4 power. And again, we're going to convert this over so we can simplify. So C is equal to 72. This will be the 256 under the radical. The 4 is the index. And that power of 3 will go out back, right? And so C is equal to 72. The 4th root of 256 is just 4, because that's 4 times 4 times 4 times 4. To the 3rd power. And so C is equal to 72. 4 to the 3rd, so 4 times 4 times 4 is 64. And finally, multiplying this out, 72 times 60, 4,608. So this tiger, right, this tiger needs 4,608 calories per day. Because remember, word problems require word answers. All right, so example B, we'll save that one for class. But if you want to try it on your own as a part of your notes, try it, see what you get, and then we'll look at it in class together. So that's it for today. Make sure you look at, make sure you take your notes, make sure you finish out that Google form, and I will see y'all next time.